So here we are solving a rate problem. When we do this, we have to keep in mind our rate formula, which is rate is equal to distance over time. If we change that to symbols, it's R is equal to D over T. However, when you read the problem, they're asking for time, so I just rearranged it. So I would solve for T, and you get time equals distance over R. Also, let's keep in mind our variable here. We want to know the current, so I'm calling it X. Alright, and last we have to set up our chart, which you can see here. Alright, on the left, because we're speaking about upstream and downstream, and then my columns are going to be rate, distance, and time. Now in the problem you can see the motorboat is going 35 kilometers an hour. So the rate going upstream, you would actually subtract x from it because it's going against the current. So you'd have 35 minus x, where downstream the current is helping you, so it'd be 35 plus x. Okay, the distance, a trip of 48 kilometers, so the distance would be the same for both, so we would just put 48 and 48. Okay, now is when we use our formula. T is equal to distance over rate. Okay, so the time for the upstream would be 48 divided by 35 minus x, and the time for the downstream would be 48 divided by 35 plus x. Alright, now we'll go back to the problem because we need another piece of information for our equation. And it does say that he goes upstream and back in 2.8 hours. So if I add the times for the upstream and downstream, that should be 2.8. Alright, so we get 48 over 35 minus x plus 48 over 35 plus x is equal to 2.8. Alright, now we have a fractional equation. Okay, so we have to think of our least common denominator. And here it would be 35 minus x times 35 plus x. Okay, we have those two parentheses being multiplied together. Okay, when we solve the fractional equation, we will get 48 times 35 plus x plus 48 times 35 minus x is equal to 2.8 times 35 minus x, 35 plus x. Okay, when we simplify this and put it into standard form, you get 2.8 x squared minus 70 is equal to 0. Okay, and if you solve this equation, you would now get x is equal to plus or minus 5. Now, since we're dealing with a current, which should be positive, the final answer would be 5 kilometers per hour.